guys, my name is JJ Khoza. On this lesson, we are starting analytical geometry. Analytical geometry. It means that we are using algebraic methods to study geometry. Okay? And geometry is all about shapes and sizes. We have done our algebra from the previous series of algebra fundamentals, and I hope that your algebra is good by now. If you have not done those lectures on algebra, I urge you to go back and do the full 8 lectures so that you can be able to catch up with me. Because right now there isn't a lot of algebra that I'm going to explain. It is only applications. So guys, what I'm going to do in this lecture, I will start by teaching you everything about gradient. We're going to learn about gradient. So under the topic of gradient, I'm going to teach you 5 things. I want you to know that when we're talking about gradient, there are 5 things that we talk about. Alright? 5. In gradient. Here we're talking about the average gradient that passes through 2 points. Average gradient of a line passing through two points. Okay. Now, the first thing that I'm going to teach you, this is just a layout of this lecture. So the first thing I'm going to teach you about average gradient, how it is calculated. Number 2, I'm going to teach you about the applications of gradient. When we apply gradients, we can determine if the 2 lines are parallel. So it is the application, right? Application of gradients, of a gradient. You know, a gradient, we use it. So here I'm going to have 2a. On 2a, we're talking about perpendicular lines. I'm using this notation. I'm sure by now everybody knows that this line means notation. This notation means perpendicular. And then secondly, we're talking about parallel lines. This double forward slash lines. Okay, the double forward slash means parallel. I'm sure you know. So this is perpendicular. This is parallel. And C, we use it to determine collinear points. Right, I'm not going to explain what these things are at the moment. I'm just giving you a layout. Right, and the third thing that I'm going to teach you is angle of inclination. Angle of inclination. Angle of inclination. Right? These are the things that we are going to discuss. I hope you can see and you can follow them. So these are the 5 things that we're going to talk about. Average gradient, parallel lines, perpendicular lines, collinear points, and angle of inclination. I want you to know right from the onset, guys, that when you think about a gradient, you think about the average gradient, and you think about its applications. Okay, when you get to metric at grade 12, we talk about gradient in calculus, and when we do that, we discuss first derivative. It is a gradient. I'm not going to talk about that now. Right, let us move to the second slide. Average gradient. This is the topic on average gradient. Average gradient. Okay, on average gradient, what is it that we are learning? We are learning to calculate the average gradient. There is a formula for average gradient. Let's say maybe the gradient of line AB, it is equal to, I like to put this, change in y over change in x. I like this. You will see why. It will come back. We are still going to use this formulation. Now, we all know that the horizontal is x-axis and the vertical is y-axis, right? The point of origin here in the intersection is 0. And let us assume we have line. This line, it starts at point A up to point B, right? We know that each and every point on the Cartesian plane, x and y axis is called a Cartesian plane. And we know that we always map x and y coordinates. That is how we work here. Each and every point on the Cartesian plane, its reference is with respect to x map y. So it means we use a notation of x map y to represent a point. Therefore, on point A, we are having x corresponding to A, map y corresponding to A. Also on B, we have point B, x corresponding to B, and y corresponding to B. Okay, I think this is straight. Okay, so now we want to calculate the gradient. What is it that we are actually looking at? We are looking at the vertical rise over the horizontal distance. That is the gradient. What are we going to do here? We want to see the change in terms of y, or the difference in height. So you start at the bottom right up to the top. So we're going to take the top value and subtract this, the smaller value, all right, to the corresponding point. Now, for B, we've got YB subtract YA. We want to see the change or the total height with respect to a vertical rise corresponding to the y-axis. Similarly, a horizontal distance between these points. So we have x sub b subtract xa. This is the equation for calculating a gradient, average gradient. With this equation, you get the average gradient of a line. So it happens that they may not ask you, to calculate a gradient is a simple question. It's straightforward. What if they give you the value of the gradient? Well, you just you change the equation, because if you are given the value of the gradient, it means they are in fact asking you for a value, one of the values between the x value or the y value. It could be ya or yb or xa or xb. You will be expected to make that particular variable subject of the equation. I'll just show you how you could do it. So you take this, you multiply here, all right, and you get MAB into XB minus XA is equals to YB minus YA. And then it depends which variable you want to make subject of the equation. And here you can see I'm seeing a distributive property here. So you will multiply the gradient of line AB, the average gradient, with x sub b and also with x sub a. Then it depends on the variable that is unknown that you are supposed to solve for, and then you make it the subject of the equation. I think that is clear. That is all about average gradient. All right. Let us talk about the applications of gradient. Applications. Applications. I'll write it in red, it's fine. Applications of gradient. Application of gradient. The first one, I'm writing in blue. The first one, A. We are talking about perpendicular lines. Perpendicular lines. How do we see perpendicular lines using gradients? Well, the theory says the gradient of line 1 multiplied by the gradient of line 2 must be equal to -1. Simple as that. So if you take line 1, the gradient of line 1, you multiply it with the gradient of line 2, what value are you going to get? If those lines are perpendicular, you are going to get -1. You must get -1. That means these lines are perpendicular. So you can imagine perpendicular, they meet at 90 degrees. This is line 1, it could be line 1, and then it could be line 2. The second application of the gradient, there are various things you can do here. You may also want to know, if they tell you that a particular line is perpendicular to a line with this gradient, they give you the value of the gradient. Let's say maybe they give you the gradient of line 2. So they are asking you to determine the gradient of line 1. So this is how you will find it. You simply divide by m2 both sides, -m sub 2. Similarly, if we are looking for m2, you are going to divide by m1. This is it. Right. Let's move forward. This is pretty simple and is easy to follow. You just have to know that in gradient we learn about 5 things. The first one is the average gradient and then the applications. The second application, we are determining if the lines are parallel. So parallel lines. We want to see if lines are parallel. and we're using these gradients. Oh, good. Not the same ink. Parallel lines. Parallel lines. What about parallel lines? The parallel lines, the gradient of line 1 is equals to the gradient of line 2. Simple. If you see two lines, let us say you have these two equations. Y is equals to x plus 3 and y is equals to x minus 7. These lines are parallel. Why? Because their gradients are 1. The gradients are 1. So these gradients, they are equal. Therefore, the lines are parallel. Number 3. We may also want to determine if points are collinear. Collinear points. So let us say you have a line like this, and it has got point A, point B, and point C. This is B. We want to know if points A, B, C are collinear. What does it mean, collinear? It means it's points that lie on the same line, and the same line has got a similar gradient throughout. Right, so we are going to use gradient. We're applying gradient again. So we are going to determine the gradient of point A, AB, and that gradient must be equal to the gradient from point B to C. So that in other words, it means the gradient of this portion here must be equal to the gradient of this portion here. If these gradients are equal, it means then the 3 points are collinear. It means they lie on the same line. That is all about the applications. Let us do the last one, the last part. The last part, it was number 3, and we spoke about the angle of inclination. We're still going to talk about this on our trigonometric lectures, but in short, it is tan theta equals to m. M, the gradient, the one that we just calculated, equals to m. And we know that m is equals to change in y over change in x. Or we can just state it as y over x. And this one, we can specify and say theta is an element of, so theta is the angle, So when we specify it, we say theta is could be from 0 to 180. Could be from 0 degrees to 180 degrees. Why do we say so? Again, we come to the Cartesian plane. We are allowing that the line can go like this, from 0 degrees to 180 degrees. We know this thing. Okay. We may have two conditions here, whereby the gradient is greater than 0. What if the gradient is greater than 0? We say theta is the element So a theta, the gradient greater than 0, it means we have a line with a positive gradient. Therefore, this line will lie between 0 degrees up to 90 degrees. Alright? But if the gradient is less than 0, we have a line with a negative gradient. It means angle theta is the element starting from 90 degrees up to 180 degrees. Because here we have 0 degrees, here we have 90 degrees, here is 180 degrees, this is 270 degrees, this is 360 degrees. That is it. What more could you want? That is all about gradients. So let us stop it right there. Okay guys, please subscribe to my video, subscribe to my channel, like this video, give it a thumbs up, and share it with all of your friends. Distribute it all over the world